Good morning, chemistry students. This is Mrs. Krumschreider with your Chapter 7 Day 1 notes. We're going to start on your outline at the review, and we are going to go through the factored label method review. A lot of today is going to be kind of review or things that you've learned previously in science classes. But we are going to start to talk about the mole, and you're going to discover that a mole is very important to science and to chemistry specifically. So here we go. We'll start with that review. So hopefully you have a pretty good idea of what mass is. Really, the scientific definition of mass is that mass is a measure of the amount of matter that an object contains. Right, so typically an object that has more mass is typically oftentimes larger than an object that has less mass, right? Another way to kind of think about that is a person with more mass will weigh more than a person with less mass. Here on Earth, we talk about weight because we can't escape gravity. And weight technically is the pull of gravity on a particular mass. Mass and weight are directly proportional. So mass, again, a measure of the amount of matter that an object contains. In terms of units, the SI, base unit of mass, is the kilogram. We typically aren't going to use the kilogram. We typically will use the gram, but remember SI means Le Système International de Unité, that international system of units that's used by scientists around the world. Okay, so again, all scientists around the world know how much a gram is and know how much a kilogram is, and that's typically how we measure mass. Volume is defined as a measure of the space occupied by a sample of matter. Okay. Again, when you think about this, you can think about like the volume of a pillow versus the volume of a can of green beans, right? Typically, the volume of a pillow is much larger than the volume of a can of green beans. So it's a measure of the space occupied by a sample of matter. Typically, the units for volume are either liters, which are abbreviated with a capital L, or milliliters, which is abbreviated with a lowercase m for milli and a capital L for liters. Okay, so mass, volume, again, you've probably learned about mass before in previous science classes. Volume you certainly have learned about in your math classes in the past. So we also want to talk about what an element is. The definition of an element, one definition of an element is the simplest form of matter that has a unique set of properties. Unique meaning it's different from everything else. Okay. Another way to kind of define an element is to say that an element cannot be broken down into simpler substances by chemical means. So basically what we're saying is that the element is the smallest piece that something can be. Okay, we can't break it down into smaller pieces. Remember, compounds are actually going to be made up of elements. So a compound is a substance that contains two or more elements chemically combined in a fixed proportion. Right? That fixed proportion is important because, for example, water is always 2 hydrogen atoms to 1 oxygen atom. That's what makes water water anywhere in the world. When you have 2 hydrogens bonded to 1 oxygen, that compound is water. That's what we mean by fixed proportion. We're just saying that a chemical formula is the same no matter where in the world you find it. An atom is defined as the smallest particle of an element that retains or keeps its identity in a chemical reaction. I don't know if you could hear that or not, but my dog is waking up. Now that my children are up, the dog is up. Okay. So again, this idea, we kind of talked about this with atom, right? We can have a big chunk of element, and oftentimes we use the term element and atom. Hey, Layla, stop. Atom and element interchangeably. Really the difference between them is an element is a whole bunch of atoms together, whereas an atom can be just one individual atom. We often also say that if we have a big chunk of element and we're going to chop it up into smaller pieces, but we want those pieces to still have all the properties of that element, that smallest piece that I can chop an element up into is an atom. Stop. Out. You need to get out. Okay. So again, element and atom, oftentimes your book, often I am going to use them interchangeably. Okay, and that's not really a big deal because an element just means you have a bunch of atoms that are the same together. An atom means you've kind of chopped up that element into its individual pieces and you have that smallest piece of an element that still has all the properties of that element. Then that's an atom. A molecule is defined as a neutral group of atoms joined together by covalent bonds. Remember, in a covalent bond, we have a sharing of electrons to get an octet, and covalent bonds exist in covalent compounds, which are molecular compounds. And remember, we know something is a molecular compound because it's made of two nonmetals. So molecules typically are going to be made of two nonmetals. An ion, okay, is an atom or group of atoms that has a positive or negative charge. Remember, ion's kind of generic. Specifically, if my ion has a positive charge, I can call it a cation. Specifically, if my ion has a negative charge, I can call it an anion. Okay. And again, remember, it can be a single atom. For the main body of the periodic table, remember, you should be able to figure out what charge the tall columns of the periodic table have, right? Remember, group 1A has a charge of positive 1, group 2A has a charge of positive 2, group 3A, which is pretty much aluminum and boron, have a charge of positive 3, group 5A has a charge of negative 3, group 6A has a charge of negative 2, and group 7A has a charge of negative 1. Remember, those charges relate again to getting an octet, to being like a noble gas. So again, they either lose those valence electrons to become positively charged or gain valence electrons to become negatively charged. Okay. Remember, for the short columns of the periodic table, the transition metals, and underneath our heavy stair-step line, then you're going to use your helper sheet, okay, to figure out the charge of ions. And then when we talk about groups of atoms, remember, we're talking about those polyatomic ions. Remember, you could have a polyatomic ion quiz at any time. Make sure you are studying and know your polyatomic ions. Okay, so that's kind of our review of ion. A formula unit is defined as the lowest whole number ratio of ions in an ionic compound. Remember, we know something's an ionic compound because it's made of a metal and a nonmetal, or it contains a ionic or a polyatomic ion. Remember to write the formula for an ionic compound. We do symbols, charges, crisscross, lowest whole number ratio. Okay, and again, we know that it's an ionic compound. It's a metal and a nonmetal, or it contains a polyatomic ion. Remember, for molecular compounds, to write their formulas, the prefixes become subscripts. And we know it's a molecular compound because it's made of two nonmetals. At the end of your chapter 6 notes, you made a flow chart. You are probably, if you're not feeling real confident with writing chemical formulas for compounds, you probably are going to want to find that flow chart and have that flow chart handy throughout all of trimester 2 of chemistry, okay, but through all of part B of chemistry. Lastly, what we've just talked about recently, okay, this factor label method or dimensional analysis is a technique of problem solving that uses the units that are part of a measurement to help solve the problem. Right? That's what we were just doing in chapters 3 and 4. We looked at what our given was. We looked at the unit on our given, and our unit, if it was in the numerator, it had to be in the denominator, so it would cancel out. And again, we were looking at those units as a way to know whether or not we've solved our problem correctly. When we use the factor label method or dimensional analysis, we use a conversion factor, which is a ratio of equivalent measurements used to convert a quantity or amount from one unit to another. And remember, part of the power of a conversion factor is I can write it with my units either in the numerator or denominator, depending upon where I need them to be in my dimensional analysis problem. So that's a quick little down and dirty review of some of the terms that you've learned in previous science classes as well as in chemistry in the past. So moving on, we're going to talk about a mole. A mole is extremely important to chemistry. For those of you who are going to continue and have to take a college chemistry class, you will definitely deal with the mole in your college chemistry class. Okay, so the mole is a way to measure matter, and we're going to start kind of with what is a mole. Keep in mind that chemistry is a quantitative science. All that means is we use numbers and units in chemistry. Just like physics, physics uses numbers and units as well. Biology does a little bit, but definitely not to the same extent that you do in physics or in chemistry, okay? So in chemistry, we're going to deal with numbers and units regularly. And again, chemistry B is about all of this math and all of these numbers and units. And, okay, you must be able to measure the amount of matter you have. And you actually are familiar with measuring the amount of matter that you have. So as we kind of talk here about how can matter be measured, I'm going to ask you to kind of think about your everyday life. Think about going to the grocery store. Think about going and getting gas, okay? Think about different ways that you measure your matter and you pay for your matter, okay? So how can matter be measured? We're going to talk about 3 ways that we can measure matter. Our first way, okay, is that we can count. Okay, so we can count to determine how much matter we have. Some examples, some kind of everyday examples of counting is that we count sometimes the number of apples. So we can buy sort of individual apples at the grocery store. We also might count the number of files of music that you have on your device. Okay. We count the number of people in a classroom. We count the number of pets that we have, right? There are lots of types of matter that we count when we measure them. A second way that we measure matter, this one you should be able to think about when you go to the grocery store, is by mass. some examples of measuring kind of everyday matter by mass is when you buy 5 pounds of potatoes, like you might have for your Thanksgiving dinner. You buy 1 pound of candy, right, at Halloween time. You buy your candy in bags that are measured by weight. Okay, your meat that you buy at the grocery store, again, you measure that by mass. So again, there are lots of examples in your life of when you measure matter by mass. A third way that we measure matter is by volume. For example, when you buy your gas, you measure your gas by volume, right? You pay per gallon. It's this price, like right now it's what, about $1.85 to $2 per gallon. So you buy it per gallon. This is also true of like when you buy milk or orange juice, okay, or things of that matter. My daughter's crazy about apple cider right now, right? So those are all things that you buy by volume, right? You can buy a half a gallon, you can buy a gallon, you can buy a pint, you can buy a quart. Okay, those are all examples of matter that you're measuring by volume. Typically, things we measure by volume tend to be liquids because it's oftentimes easier to measure them by volume. We also, in our everyday life, have some units that indicate a specific number of items. For example, a pair, right? If you go to the store and you buy a pair of shoes and you get home and there's only one shoe in the box, that's a problem, right? Because a pair means that you bought two, okay? So again, pair means two of something, okay? Dozen, right? You buy a dozen eggs. Again, if you don't check your eggs in the grocery store for some reason, and you get home and you open up your package of a dozen eggs and there's only 11 eggs in there, you're going to be mad because you bought a dozen, which means you were supposed to have bought 12 of them, okay? So dozen, right, is again one of those special terms that means 12. We also sometimes have a baker's dozen. Right, so if you go to the bakery and you order a baker's dozen of something, typically that means you're going to get 13. Okay, so again, we do have some units that indicate a specific number of items. That's important because what we're going to see is a mole also is going to indicate a specific number of items. Okay, so it's important that you understand that we have some units that when we talk about a dozen of something, we know that means we're talking about 12. If we talk about a baker's dozen, we know that means we're talking about 13. If we talk about a pair, we know we're talking about 2. What you're going to see is when we talk about a mole, we're going to be talking about 6.022 times 10 to the 23rd of something. Okay, so a mole is going to indicate a specific number. So we're going to kind of get started delving into what a mole is. So you will see that a mole indicates a specific number. And if you didn't catch that number when I said it, it's okay. So we're going to talk about it in next week. Okay? By knowing how the count mass and volume of an item relate to a common unit allows you to convert among those units. And what we're going to see is this common unit in chemistry is going to be a mole. Okay, so again, that's sort of a little preview of what's coming. We're going to end today with, again, a factor label method review. I know it's fairly fresh in your mind, but we're going to kind of do one more example. For this example, we're going to assume that 2 kilograms of apples is 1 dozen, and that each apple has 8 seeds. So that assumed term is kind of a clue that we're probably going to have to use this information as a conversion factor to solve this problem. So we want to know how many apple seeds are in 14 kilograms of apples. Again, not a particularly wordy story problem, but again, I just like to summarize. So this is asking me to take 14 kilograms of apples and figure out how many seeds that is. So again, I'm going to start with my 14 kilograms of apples. Kilograms of apples has to be on the bottom. And I see up here that I can relate kilograms of apples to dozens. So we're going to do dozen, right? So we know 1 dozen is 2.0 kilograms. And kilograms of apples is crossed out. We know 1 dozen, and we'll just kind of put an A behind here for apples, okay, is 12 apples. And we know that 1 apple has 8 seeds. So apple to seeds, we know 1 apple has 8 seeds. And we wanted to take kilograms and figure out seeds, which we have. Again, remember we're multiplying by numbers in our numerator. So again, hopefully you don't need to type a 1 in, but you're going to multiply by 12, you're going to multiply by 8. Remember, you're going to divide by numbers in the denominator, so you'll end up having to divide by 2. So again, how I would type this in my calculator is 14 times 12, and I might even go ahead and put it in parentheses, times 8, close my parentheses, divide by 2, and then hit my enter key. Okay, so I take parentheses 14 times 12 times 8, divide by 2, and I get 672 seeds. Now, we do need to look at significant figures. 14 has 2 significant figures. Okay, this one has 2 significant figures. This is a definition, so it would have unlimited. And we can really kind of say this is a definition as well, and therefore it has unlimited. So based on that, I really should only have 2 significant figures. So I need to rewrite this with 2 significant figures. So my answer is really 670 C's. Okay. So that brings us to a good spot to stop. Next week, we're going to work and talk about the mole in a lot more detail. We'll be using your calculators a lot, as well as your periodic tables. You don't have any homework, so enjoy your weekend, and I will talk to you later. Have a great day.